Okay, so here we go. Measurement lesson 1, review and preview. Looks like we're going to be doing some unit conversions. I will get you a formula sheet. The first thing you need to use is this metric number line, which is based on powers of 10. So let's just zoom into this on your page. Obviously, the thing in the middle, where it says unit, that's going to be your standard. So for example, if you're talking about length, we would use the meter. So then those letters will represent the prefixes. So like you have deci, centi, and milli. This is all review from probably elementary school, as well as Math 10, some junior high. This will go pretty quick. DA stands for deca. This is hecta or hecto, I can't remember. And then this is kilo. Nobody uses hecta, nobody uses deca. I never see deci. I've seen some centi. In Europe they use it for their beverages. So like a can of pop would be like 35 centiliters. That's the only place I've seen that. But you see a lot of millimeters and you see a lot of kilometers. So you see a lot of kilo and milli. Now, using the chart and using the powers of 10, you have to remember this, and it's pretty straightforward. If the unit gets larger, the number gets smaller. It's inversely proportional like that. And then vice versa. If the unit gets smaller, the number gets bigger. And it's all based on factors of 10. So am I timesing by 10 to make it bigger? Or am I dividing by 10 to make it smaller? So for example, if you had 5 meters, how many millimeters is that? Count the jumps. 1, 2, 3 jumps from meter to millimeter. So how many times do I multiply by 10? Times by 10, how many times? 3 times. So 5 meters is how many millimeters? 5,000. Okay. Written using powers of 10 would be like this. 5 times 10, 3 times. So from meter to millimeter, the unit got smaller. What'd you notice about the number? It got larger. Okay, so I just visualize the meter stick. How many little ticks are on there for a centimeter? Here's a meter, right? How many little ticks to get? How many centimeters on the meter? 100 little ticks, right? Because the smaller amount of divisions on a larger thing, the number must get larger. Okay, so let's try another one. This one here, you can see unit got smaller, so number gets bigger. Let's go the other way. Let's go the other way. And we'll do a nice one. Let's say you have 350 centimeters. How many meters is that? How many meters is that? Someone did it so quickly. Why is it so easy? That's the whole point. It's metric. Metric is supposed to be easy. It's just sliding the decimal left and right. So from centimeter to meter, how many jumps? And the unit is getting bigger, so our number should get smaller. So 350, you would have to divide by 10 how many times? Twice, because 2 jumps. So you would have 2 decimal moves. This would be 3.5 meters. So easy, right? Okay, good. Once you can do metric once, you should pretty much have it. This chart here underneath, this will be what you'll see on your formula sheet. you will have this number line and you will have this chart on your formula sheet. So you don't have to memorize any of this, and that chart is given to you. Okay, so the number lines for metric, so make sure you put a star on this. This is for metric, and then this chart is for anything involving imperial. So it could be imperial or imperial to metric. Now imperial is like the American system. The entire world uses metric. Remember that SI stands for the international system, and it's metric. So SI is metric. Imperial is the old system from England, and the Americans still use it. And we even use it, obviously, in our day-to-day life. Like, how tall am I? If I stand up, how tall am I? About 6 feet. Very nice. Good estimate. And nobody would say I'm like 185 centimeters, would they? Your driver's license does, though, right? And how many pounds do you think I am? How much do I weigh? It starts with a 2. I was 225 actually in July, and I lost weight. So I'm at 207 roughly right now. So that's pounds though, right? But on your driver's license, what would it be in? Kilograms, because that's metric. But nobody talks about like that way. So we do use imperial in our day-to-day lives, but in anything that involving like a science or like your anything involved with the government, it would all be metric. So these on your chart, we'll use proportions for these. Whereas metric, we just use that number line. With the imperial stuff, we'll use proportions. So you can cross, multiply, divide, or you can do the unit analysis. You might have learned that in science class. Okay, and when we do some class examples, you'll see how that works. Okay, so let's go to class example 1. Let's do some metric. Let's do some metric. All right. All right. So meter to centimeter, what you can do right now, just jot them down. You got km, hm, DAM, and then meter. Put that right in the middle. And then you have DM, CM, MM. Now all you have to do is count the jumps. So how many jumps from meter to centimeter? 1, 2. 2 jumps. And the unit got smaller, so the number gets bigger. So I times by 10 twice. 1 times 10 squared would be 100. So a couple things went by pretty quickly. The number of jumps is just from the units. And then the reason that I'm timesing is because the unit got smaller. Okay, now take a look at the next one. Liter to milliliter. The number got, or pardon me, the unit got smaller, so the number should get bigger. So I need to multiply by 10. How many times? From the standard, liter is just like meter. It's the standard. It's in the middle. How many jumps to get to milli? Good. 3 jumps. So I would times by 10 3 times. And you get 2,300 milliliters. Any issues with that so far? This should feel pretty comfortable for you guys. Yep, good. 750 centimeters. Now, centimeter to meter, how many jumps is that? 2 jumps, and the unit got larger, so the number should get smaller. So I have to divide by 10 how many times? Twice. That accounts for how many decimal moves? 2. And one more, mg to kg, that's milligram to kilogram. Okay, milligram would be like how much sodium is in your noodles that you're about to eat, and kilogram would be like sacks of potatoes. So understand the difference there. 72,000 milligrams. Wow, that's kind of weird. So switch to kg. How many decimal moves? Mg to kg. 6, right? So m, and then you got to go 1, 2, 3, 4, 5, 6. So 6 decimal moves. And am I dividing or am I timesing? Why do I divide? Because the unit is getting bigger, so my number should get smaller. Divide by 10 to the 6. So you could literally type 72350 in your calculator and divide by 10 6 times. Divide by 10, divide by 10, divide by 10. Or you could type in a power like that. Or you can do the decimal move. So right now the decimal is all the way on the right. And then you can go 1, 2, 3, 4, 5, 6. So that means it's 0.072350 kg. That's how you do it by hand. I personally wouldn't do it by hand. I would just type it in my calculator. Okay? So in terms of calculators, this is the one that you'd probably want to have. This is the best one, okay, or something like it. The older ones aren't as good because you can't go up and copy paste, but this one you can. So I would just go 72350, and then I'd hit divide, and then I'd go at 10, and then I hit the power button, and I'd put a 6, and I would get exactly that. No thinking involved. This is beautiful. Okay, let's keep going. Let's do imperial. Imperial, like I said, is going to use proportion, and the one that they want you to do is go fraction equals fraction and then cross multiply. Okay, so you've probably seen something like this before. So let's take a look at this one. Here they're going to talk about some model dinosaur. I'm not going to read it. I just see this right here. So that's the conversion factor right there. 1 centimeter is equivalent to 2.1 feet for this model dinosaur, whatever it is. It's a model. It's a scale factor. It's like when you write a map down. 1 centimeter might represent 1 kilometer. Now, what other information did they give us? This guy here. Notice the unit. What unit did they give you? So it must go with the centimeters here. And then that means you're solving for x feet, and you just need to cross multiply. So cross multiply. You always divide the thing across x. Which one's across x? The 1. So I need to times these two guys. So 2.1 times 12.5, and then I divide by 1, and this will equal x. Just remember that. You always divide the thing across the unknown. So I'll just do that for you on my calculator. 2.1 times 12.5, I got 26 and a quarter. And that, what unit would that be in? Feet. Okay, the next one wants us to go mile to inch. So flip your page over and go look for mile to inch. Do you see one? There is no mile to inch. For some odd reason they didn't give it. So what you have to do is go into a two-step. Maybe go into feet or something first. Okay, so mile to inch. We'll have to go to feet first. and then we'll go to inch. So what does the formula sheet tell us about miles and feet? Let's just do this one first. So write that down, and write that down with the unit. It helps immensely. 1 mile is 5,280 feet. Now I can convert the thing they gave me, which is 0.05. I know it's miles, so I will line up the units. Notice how I just line up the units, and then I can solve for x feet. Cross multiply, and you get 264 feet. All I do is times those two. And dividing by 1 is not going to change anything. So now I need to do the second step. Now I got to go from feet to inch. What does the formula sheet tell us about feet to inch? 1 foot is 12 inches. What do I have? 264 feet. So where does that go? The left or the right? Line up the units. So this one will be 264 feet, and this is x inches. Now, how to solve this one? Do I times or do I divide? Times these two and divide by 1's not going to change anything. So it's a times. 12 times 264, and you get 3,168 inches. Does that make sense? You went from feet to inch, the unit got smaller, so the number should get bigger. Good. Any questions about that? Tia, we'll get you those notes in a bit here, okay? Okay, so for the next one, it's the exact same question, but we're going to use this thing called unit analysis. Okay, that's what they're calling it, unit analysis. This is what they would do in a physics class or like a science class. You just cancel units. It's quite nice. It's always times, except some stuff goes in the bottom. So it's like you're timesing the reciprocal, so it's really division. And I'll show you how it's done. You start off with what they give you, 0.05 miles. And if you remember, we don't have a miles to inch. We got to go miles to feet first. So what you're going to times by is some proportional relationship where miles is in the bottom. Why would we want that? Very nice. So then the miles would cancel, and you'd be left in feet. This is by far the easiest way to do this stuff, I think. And I know that in 1 mile, there is 5280. Do you remember we times by 5280 in the last example? Okay, so we know we have to do that. Now let's keep going. Now I want feet to go away, so where should I put feet? In the bottom. And what goes in the top? The thing that I want will be inches. And I know that in 1 foot there are 12 inches. Now the feet will cancel. And you get the exact same solution. Just looks nicer. Or it looks different, I mean. So it should be the exact same number, 3168. And you're left in inches. Miles canceled, the feet canceled, and you're left in inches. And you can see here on the bottom, class example 5, they're referencing physics. This is done in the physics 20 class as well, this sort of conversion. So it looks like they're talking about rate of speed here. You got meters per second to kilometers per minute, and we want to convert. So let's just write this down. 75 meters in 1 second. That's what this represents. And we want to get to kilometers per minute. We don't want meters up top, we want kilometers up top. And we don't want seconds on the bottom, we want minutes on the bottom. So let's just work with the meters first. I want the meters to go away, right? So it needs to go in the bottom. And I want kilometers to show up. So kilometers needs to go in the top. That's the hard part. You need to think about that. So, and is it that hard? You just want something to cancel. So meters got to go away, put it in the bottom, put kilometers up there. And then what's the relationship between kilometer and meter? 1,000. So where does the 1,000 go? In the top or the bottom? Good, because in 1 kilometer there are 1,000 meters. So we're timesing by 1/1000th, which means you just divide 1,000. If it's in the bottom, just divide. Okay? Meters are now gone. Now we're in kilometers per second, but we don't want that. We want kilometers per minute. So what do we need to do to that S? Get rid of it. So S is in the bottom right now. So put S in the... Good. Put a times, put S in the top, and we want minute here. Now what's the relationship here? 60. Where does the 60 go? Top or bottom? Good, because in 1 minute there are 60 seconds. Now the seconds cancel. So now you go to your calculator and go 75 times 60, divide the 1,000. You get 4.5. How'd that feel? Okay, that's like the start of Physics 20 or maybe some Science 10 in there. So in terms of difficulty, not too shabby. So unit conversions and now some slope. And then that's it for today. Okay, so we just have to take care of slope. So if I say slope, you guys will probably say rise over run. All slope is a measurement between two quantities, the y quantity and the x quantity. Okay? Let's do one that you probably are all familiar with. D versus t, distance versus time. Let's say that you cover a huge distance in a really short amount of time. How steep is this line? Pretty steep. Why? In a really short amount of time, you covered a lot of distance. So are you moving quickly? You're moving quite fast, right? What's the opposite of that? You spend a ton of time covering like a little bit of distance. You're moving slowly. So what are we talking about? We're talking about speed. What's the formula for speed? D over T. What's the unit for speed, like in your car? Kilometer per hour. So you have km per hour. You guys know that, right? Speed, km per hour. Notice km's in the top, hour's in the bottom. D over T. What is the D? It is delta y. What is the T? It is delta x. If you can remember that, you'll never forget slope. Just think kilometers per hour, delta y over delta x. I can do this. The slope of a dt graph is just the speed. So m they use for slope. So slope for a dt graph, they call it speed. What about slope for a VT graph? Anybody know that one? Acceleration, very nice. How fast is the speed changing? That's acceleration. So there's all types of different slopes, okay? The one that's most famous though is speed. Okay, calculating slope by hand, you need 2 points. Okay, let's go on this graph. Find the point A and find the point B. Remember, the first coordinate is the left and the right, and the second coordinate is the up and the down. It's like you're playing Battleship. So what's this first coordinate? 1, 8. You guys okay with that? It's 1 over and 8 up. Okay, what's the other coordinate at B? 7, good, and 11. Okay, we know that slope is equal to delta y over delta x. Now, without being all mathed up, let's just be smart people. Like you, this is real life, not math class. How much did the x change? It started at 1 and it became 7. How much did it change? So delta x is 6. Don't follow some formula. Just think. How much did the x change? 1 became 7. So delta x is 6. What's delta y? 3. And then that fraction, 3 divided by 6, if you stink at fractions, just go 3 divided by 6, hit the math button, and then hit enter, enter, and you get 1/2. The fraction's 1/2. What does that mean? The fraction's 1/2. Yeah, lowest terms, very nice. That means if you go over 2, you would have to go up 1. Because the run is left and right, and the rise is up and down. And that is linear 2 over 1 up. That never changes, and then therefore you have a straight line. If you want to get into trades, you got to know slope. Like I built a woodshed at my lake this year, and we did a pretty simple slope, a 1-2 slope, exactly like this. That would give you like a little 30-degree angle in here. So we cut some boards with the saw, and we made a roof. Why do you think in Alberta you need a sloped roof? Snow. So, yes, I'm a math teacher, and yes, I built a pretty simple wood shed this summer, but it took some math. Math is everywhere, so not just in the class. Let's do the next one. This time, let's just actually use the formula without any thinking. Let's see if we can do that. So what's this point at C? 6, 5. You guys okay with that? What's this next one? 10, 2. You guys okay with that? Okay, let's do this formula. M is y2 minus y1 over x2 minus x1. Okay, the y. Which ones are y's? 6 or 5? The 5, right? And 10 or 2? Which one's the y? Good. So without doing any formula, how much did it change by? 5 became 2. It dropped by, careful, it dropped by 3, so the change would be delta y would be -3. Okay, so that's why here you go 2 minus 5. Well, I could have did 5 minus 2. Why do I do 2 minus 5? Because you see how it says y2? Just use the point on the right. use the second point. Call this one 0.1, and this one 0.2. So like this would be x1, this would be y1. This would be x2, this would be y2. So 2 minus 5. Now how about the x's? You have a 10 and a 6. 10 take away 6. So you get a negative 3 over a positive 4. What's a negative divided by a positive? The entire fraction is negative. So this guy is negative 3/4. That's the slope. So every time you have a point on this line, it'll always be 4 to the right and 3. 1, 2, 3, 4. 1, 2, 3. So the next point would be 1, 2, 3, 4 over, and 1, 2, 3 down on that line. It's a step ladder. All right, folks, you guys are rocking. I'm impressed. We'll finish this class example 7, and then you can work on the homework, and then I'll give you the quiz. Complete the following. Slope is a measure of the Good. Slope is the ratio of the vertical change called the rise over the horizontal change called the run. A line segment which rises from left to right. So that's this. Good. Positive slope. A line segment which falls from left to right. That would be this one. That would be a negative slope. A horizontal line segment has a slope of, just like this class, 0 fun. That is Slope Dude. You know Slope Dude? Yeah. Oh yes. Oh yeah, Slope Dude is infamous. I actually created that video. No, I'm kidding. A vertical line segment has an, ooh, they use this and. So you know it's going to start with a vowel. Very nice. Look at this guy. Math whiz. Undefined. Okay, so let's just draw that in. Vertical would be undefined. And that's because if you do delta y over delta x, what would be 0? The delta x would be 0. And can you divide by 0? So that's that divide by 0 error. That's what that is, divide by 0 error. You can't do that. And then the horizontal one, that would, again, that would be delta y over delta x. So what's 0 this time? Good, so then you have 0 over something that's not 0. Maybe it's like 5 or something. And 0 groups of 5, that would just be 0. And the slopes of all line segments on a line are the same. So no matter which points you pick, your slope will always come out the same. Okay, so for your homework, you have 1 to 6 and 13. And 7, 8, and 14. So you just follow those. It's on both pages. 1 to 6 and 13. And then 7, 8, and 14. That's how you follow. We're not going to do any of this accuracy and precision, so you guys can just go like this. We don't do any of page 5. And we're not going to do... So your homework will have, it tells you so 1 to 6 and 13. And then 7, 8, and 14. And then you stop there. Don't do any of this accuracy, precision stuff. And your assignment starts here.